Hello, everyone. My name is Chenguang Wang. I'm currently assistant professor at UCSC, and in the meantime, I'm also, I think, working with Emily also closely at Scale as a research advisor. So today, I'm going to talk about basically the post-training to evaluation. What we'll be working on, right? Try to build a frontier, hopefully, agents, using what we have already at Scale AI. Let's get started. So I think I can spend a little bit time on talking about, if you guys don't know Scale AI, right? So the mission of the company is really just try to build reliable AI systems. I think for the world's most important decisions, I think it's founded by Alex in 2016, and it's pretty big right now with many employees and the offices across, I think, US and also in I think other countries as well. But I will get straight to this topic. I think I will mainly cover, I think mainly two topics. One is the post-training, right, as part of in the title, briefly, but only briefly, because we only have 10 minutes. I think the second part will be talking about evaluation, and I try to bring some synergy between those two components, right? So I will start just with a general idea about the current research focus at the Scale on the post-training part, which is trying to, right, so like a research training is also like this, right, moving from RL-HF to rubrics-based RL, right? So I think this is a practice we got from, basically working with the frontier labs to providing the data services, and we figure out this is something really important for post-training. So there's definitely challenges over there, right? How to really design effective reward and how to use that reward with RL and how to make a reward even better during the training, during the RL phase, right? So we have been publishing, I think, at iClear this year, SML, I think hopefully we get something also at the Neurips, so on and so forth, so in middle of the response. But we are able to, I think, push a boundary of GRPO, right, by using a rubrics-based reward paradigm, right, just basically improve the performance, and is able to, I think, also gather some, I think, interesting receipt or, basically insights, I think, from the process of training and also working with the data, how to basically play with this flywheel, right, the data and RL part. Hopefully I can get something, for the takeaway for you guys today, right? So the first thing I want to focus on is really this our recipe. We actually realize it's important. I really want to highlight or avocado this is basically the rubrics-based reward, right? So this is important because I think in general, right, so if we want to make RL work, right, so previously I think the trainer is on the so-called verifiable domain, right, where you can pretty much know, for example, coding or math, you can pretty much know whether this is true or false, right? You pretty much get a ground truth verification, right? But in many real-world cases, where we really care about, or frontier lab really care about, is really you want to make this work for domains where there's no verifier, right? Whereas it's not a verifiable domain. So we need to find out a way to make it work for those open-ended domain. Could be science, could be something else, right? Could be for our personal tasks. So we are trying to basically set up this paradigm where we ask, right, basically a criterion or evaluation criterion that turn that, into verification, right? Something like that. So we are able to really, I think, build a new reward model, which is not on basically distinguish a better response, versus a worse response. We are trying to say which one is better and is ranking based from rubrics. So it can scale up to real world scenarios. And we build a reliable pipeline like we show, I think, in these two figures where we can start with something simple and gradually build a very high quality rubrics and use that in RL phrase. And we witness improvements on open-ended tasks. Right, that's a takeaway. And then this is a natural extension of the first work, right? It's also on rubrics where you train a model, but the policy will change, right? Your policy becomes better, right? Better code, right? So, but there's still something, is changing. So you have a reference policy, you have some current policy, and you figure out what is missing in the current reward and generate better rubrics or online rubrics where you can integrate this into the reward model, where then you can pretty much just train it better and be more robust to downstream tasks. So this kind of online rubrics, I think evolution, I think aligns very closely with the recent trend in, I would say, self or improvement or recursive self-improvement line of work, right? We are moving towards there. And the second part, I think that's pretty much, I just want to highlight a few research done the post-training. And I think in the evaluation space, I think it's definitely Scale's main focus is really basically driving those insights from the training and talking to the customer and then build some, I think the world's, basically worldwide leaderboard for those frontier models to be on, right? So there's many going on, but I would just want to highlight a few projects recently, right? So many of you guys definitely it's like a really working demo of agents, right? It's like survey agents or coding agents, right? I think Scale invests a lot in this domain, try to build a reliable benchmark to try to understand whether, what's the true capability of the agents, right, of survey agents. I think you guys know benchmarks such as Survey Bench Pro, where you can pretty much just think about the problem is like there's some text description about the problem in the GitHub, and you just need to ask agent to generate a patch, which can eventually just fix whatever bug in the original repo, right? But I think in the real world, it's much messier, right? Where I think as an engineer, we are not only just looking at the PR and looking at the issues and generate basically response, right, as a patch. You need to deal with those writing a unit test sometimes. You need to even figure out the problem by just basically go back and forth, look at the repo, ask some question, and answer that question so we can figure out what to do next. So that would be some insight we can borrow very differently from working with benchmarks such as Survey Bench Pro. So we released this new benchmark called Survey Atlas, right? I think it's widely adopted by Frontier Labs right now. And other than Survey, another, I think, focus of the agent eval we are building is in this professional reasoning domain or this kind of AI for science domain. I think definitely, I don't need to say too much about HLE, which is like a professional reasoning benchmark. I think people are still trying to hill climbing, right? Try to become better from different like model families, right? And also, we are also working on this drug discovery bench, which is trying to really build some real-world healthcare environment where we just work with experts, generate this real-world basically drug discovery tasks where we start from the concept and then deliver the actually the drug. We recently also released a preprint on that regard. And we are also working on tool use, right? So there is a debate on what is the best, I think, tool interface. Is this a CLI or is this MCP? I think we got an interesting, I think, conclusion, just high-levelly. We found out once a model becomes really capable, like a recent Cloud 4.8 or GPT 5.5 or 5.6, that doesn't matter. So model will learn to use the best tool interface possibly, right, in a real-world scenario. So that really doesn't matter unless you basically you give the same backend tool, right? That the interface really doesn't matter. And we are also working on this computer use agents, right? We are trying to benchmark computer use agents. So we are trying to scale up the computer use agents environment benchmark because each of the computer use agent benchmark is really very expensive to run, right? It's a multi-model, and there's many, I think, details you need to consider in terms of verifications. So we think about a way to actually based on some existing high-quality benchmark and really just generate long horizon, more challenging, more real-world tasks from based on those existing benchmarks. I think we show that we can pretty much bring down the performance of the original OS world, where I think the state of art of this, I think Opus new version is something definitely beyond 80%, bring it down to something 30%. So there's a way we can construct real-world data sets synthetically, but in a very high-quality way. This is pretty much what I want to just final slides, technical slides, where we can pretty much build a synergy between evaluation and post-training, right? Just draw insights from post-training and try to build better RL environments, and also draw insights from evaluation failure mode and try to build better post-training algorithms. Hopefully this can run forever, so we got those better eval and better training result as well. So just closing, I think Scale is working with many different frontier labs, governments, and also enterprise and robotics, right, on this physical AI. And another advertisement, I think we got this third edition of the Agents in the Wild workshop accepted at NeurIPS, right? The deadline is coming soon in the end of this month. I'm one of the core organizers there, so we have a wonderful panel of speakers, panelists. Don is there, Joshua is there, Java is there. So feel free to submit and see you guys at Sydney. Yeah, that's it. Thank you.